Hello dear students, welcome you all for transmission and distribution class. So today we will see the last part of the fourth module, that is performance of transmission line. So we are seeing the ABCD parameters. We will see one or two problems on this. So we will conclude the module. Okay. So we will see the problem, that is example 10.16. A balanced three-phase load of 30 megawatt is supplied at 132 kV, 50 Hz and 0.85 power factor, lagging by means of transmission line. The series impedance of single conductor is 20 plus J52 ohms and total phase to neutral admittance is 315 × 10⁻⁶ Siemens. Using nominal T method, determine the ABCD constants of the line, sending end voltage and regulation of the line. So they are given the values directly. Z is equal to 20 plus 50 J52, Y is J315 × 10⁻⁶. So we will see the nominal T methods. We are knowing that the values are given. What is A, what is B, what is C. I have explained in the last class. Just have that reference with you. A is same as D, which is nothing but 1 plus ZY by 2. Putting all the values here, we will get the value as 0.992 plus J 0.00315. B is Z into 1 plus ZY by 4. Put the values, you will get B as 19.84 plus J 51.82. C is same as Y, that is directly you can write the 0.315 into J 10⁻⁶ is there, no, that value you write down. Here angle is 90 because J is there, so that's why angle is 90. So you got now ABCD. You can see in this figure all the way how the nominal T method will be. Now actually we are knowing that VR is given 133 phase. Now 132 kV divided by root 3, we will get 76210 volt. IRS receiving end current, that you will find by the power by root 3 into kV into power factor, you will get 154 amps. Power factor is given 0.85, cos phi r is 0.85, we will get sin phi r as 0.53. We are taking VR as VR plus J0 and IR as IR cos phi r minus J sin phi. We are knowing these things. Okay, writing this one, we will get the IR vector as 131 minus J 81.62. So we are knowing now VS is AVR plus BIR. No, by ABCD we are already calculated. Now put VR and IR values in that one, we will get VS as 82,428 plus J 55413, or magnitude of that one is 82.6 kV, and line voltage, if you multiply it by root 3, you will get the 143 kV. So sending end voltage calculation is very easy. See, in previous case you actually your direct nominal T method means you need to find that VS is equal to VR plus IR Z by 2 plus IS Z by 2. Two cases we need to add all those things. Now see, directly if you are putting the values in ABCD parameter, you will get the VS easily. Same thing for regulation. VS is equal to AVR plus BVR, and IR at no load means IR is 0. No, that time VS will get A VR naught. VR naught is the voltage at the receiving at no load. So once we got this VR, we will have VS by A, that directly we can write, or VR naught is nothing but VS by A. Regulation, you can note down this equation. Okay, usually it is asked. See, VS we are knowing AVR plus BIR. At no load, IR will be 0. No, then what happens? VS become A VR naught. That VR become VR naught, because at no load IR, when IR is 0, VR become VR naught. The VR naught is the voltage at receiving at no load, or VR naught is nothing but VS by A. So VR naught we can write as VS by A, and regulation is usually VR naught minus VR, that is no load voltage at full load minus full load voltage. That is VS by A minus VR by VR. We will get the 9.25% as the our regulation. So next problem we will see. A132, that is 10.17, 132 kV 50 Hz 3-phase transmission line delivers a load of 50 megawatt at 0.8 power factor, lagging at the receiving end. The realized constant is given. ABCD parameters is given. See, A is equal to D as 0.95 at an angle 1.4 degree. B is 96 at an angle 78 degree. C is 0.0015 at an angle 90 degree. Find the regulation of the line and charging current using nominal T method. Directly everything is given ABCD, no need to calculate ABCD. Directly write the VR. 132 kV is given, divided by root 3, you will get VR phase. IR to calculate the power divided by root 3 into V cos phi. Cos phi is given, get the sin phi r. Get VR phasor value, that is VR plus JR, and IR, get the IR minus phi r. So once you got that one, you go for the equation VS is equal to AVR plus BIR. Put all those things, you will get VS as 92,128 plus J 18,096, or its polar value is 94,066 at an angle 11.65. So sending end current IS we will need to calculate, that is CVR plus DIR. We are knowing that one. Put the values, you will get the J current as 211 minus J36. Now charging current we want. Actually we know that IS is equal to IR plus IC. Just recall the things of the nominal T method. To get IC we can write IC IS minus IR. That sending end current minus receiving end current is the IC. We will get current as 128.2 at an angle 93.1. Regulation is same, VS by A minus VR by VR. Okay, that is 30% regulation we are going to get. The last problem we can see here. Find the following for a single circuit transmission line delivering the load of 50 MVA at a 110 kilovolt voltage and power factor 0.8 lagging. The sending end voltage, you need to calculate is sending end voltage, sending end current, sending end power, and efficiency of transmission. ABCD is given. A is equal to DS 0.98 at an angle 3, B is 110 at an angle 75 degree ohms, and C is equal to 0.005 at an angle 80 Siemens. So receiving end voltage per phase VR is given by 110 by root 3. We are knowing 110 by root 3 is 63.5 kilowatt. IR is calculated using power divided by root 3 V. We will get 262.4 as the amps. Okay, now we will take the receiving end voltage as it is, and current is in terms of at an angle 0.8 we are calculating, because the lagging current angle is given as 0.8 power factor. So I can write IR is equal to magnitude minus cos of 0.8, that is 0.36 is the angle, that 36.86 is the angle. Current you used to get is 210 minus J 157.5 amps. Now we are finding the sending end voltage. VS is equal to AVR BIR. We are knowing these common things. Put all the values. You will get the VS as the 87,427 at an angle 14. Magnitude of that is 87,427 volt. That is the phase value. If you want that line value, multiply it by root 3. Then sending end current. We are knowing IS is equal to CVR by DIR. Just put the values. You will get the current as 246 at an angle minus 27 degree. Okay, now once we got the current and voltage, next is sending end power. We are knowing 3 Vs Is cos phi s. So cos phi s is finding angle of the voltage, angle of the current minus. Okay, angle of the voltage minus angle of the current. That is 27 is the angle of the current here, minus 27, and 14 is the angle of voltage. With respect to the VR we are finding. So we will get the angle. So we will find the sending end power as the 48.6 into 10 raised to 6 megawatt. That is 48.6 megawatt. So efficiency is 40 by 48.6. We will get 82.3% as the efficiency. So to try these problems, okay, usually nominal T method problem only they are given. So if you find any difficulties, you can ask me. By this your the module 4 is finished. It means I have finished you 3 modules. In the next class we will see the next module. Okay, I will start with the module 2. A bit problematic is there, so anyhow we will go with the online classes only. So by the time being, you just try to understand the concept of this ABCD parameters, and solving the problems using ABCD parameters is very easy. You can go with this method only. Okay, if you find any difficulties, you can call me. If you find any problems, you can ask me. So while solving the problem, better movement, and whatever the problems you have solved in nominal T method, nominal phi method directly, that you put with this ABCD parameter method, easily you can find the things you can come to know. In the next semesters, like final year, you will be writing the programs for this ABCD parameters. Okay, so this is very important things in your upcoming semesters also. Okay, if you so thoroughly you go through these things. Thank you.